Hello, in this lecture I will prove the Pythagorean theorem. The Pythagorean theorem relates to a right triangle, like this triangle in the right side of the picture. A right triangle is a triangle in which one of its angles is 90 degrees, like this triangle. Actually the angle between side A and B is 90 degrees, and Pythagorean theorem says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, or c square equals to a square plus b square. Again, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. C square equals to a square plus b square. Okay, it's right in every right triangle. This sentence is true. Okay, so in order to prove the theorem, I actually copied the right triangle into the left side. So I copied by making a straight line in size of B along side A, and so A and B are on the same straight line, and then I raised a perpendicular in size of A to side B, and actually between side A and side B in the left triangle we have 90 degrees, and actually the right triangle and the left triangle both have 90 degrees angle. The angle between side A and side B in the right triangle is 90 degrees, and the angle between side A and side B in the left triangle is also 90 degrees. So they have one angle that equal to each other, and they also have two sides to equal to each other. Side A in the right triangle equals to side A in the left triangle, and side B in the right triangle equals to side B in the left triangle. So we have two triangles that have two sides that equal to each other, and also the angle between those two sides equals to each other. Okay, they both have the same 90 degrees angle, so they have two sides that equal to each other and one angle that is between those two sides that equal to each other. Therefore those two triangles coincides to each other. Okay, and if this side is side C, then in the left triangle it must be also side C, this side must be side C, according to the rule of corresponding sides in coincide triangles are equal to each other. Because of the fact that those two triangles coincide to each other, so the corresponding sides must be equal to each other. For this reason, this side, if this side is C, this side must be also C. And if we call to the angle between side B and side C alpha, then the angle between side B and side C in the left triangle must be also alpha, and the angle between side A and side C in the right triangle is unknown, so we will call it x. But we know that in every triangle in the world, the sum of its angles, the sum of its three angles is always 180 degrees. So alpha plus 90 degrees plus x must be 180 degrees. It is correct, it is true for every triangle in the world. So we can actually write that alpha plus 90 degrees plus x equals to 180 degrees, no matter which triangle we are talking on. It's true for every triangle. The sum of its angles is 180 degrees. So the sum of the angles of the right triangle, alpha plus 90 degrees plus x, equals to 180 degrees. In this equation we can subtract 90 degrees from both sides of the equation, and then we will get that alpha plus x equals to 90 degrees. Okay. Now we can subtract alpha from both sides of the equation, and we will get that x equals to 90 degrees minus alpha. Okay, x equals to 90 degrees minus alpha. Now, if we look on the middle triangle, we don't know the size of this angle between C and C, so we will call it y. the reason that I'm saying that we don't know the size of this angle is because from the beginning we assumed that this angle that is called alpha is known, but the angles that are called x and y are not known. Okay, so it is like we assume that the angle alpha is known, although that we are not really know what size this is, but we assume that the angle alpha is known and the angles x and y are not known. Okay, we know that every straight line has two sides. It has the upper side and the bottom side. This is the bottom side, this is the upper side. And we know that in each side, the sum of its angles is 180 degrees. In the bottom side, we have only one angle, and it is 180 degrees. And in the upper side, the sum of its angles is also 180 degrees. So x plus y plus alpha equals to 180 degrees. So we will write it down. Okay, the sum of the angles on the upper side of the straight line equals to 180 degrees. We have three angles in the upper side of this straight line, 1, 2, 3, and the sum of those angles equals to 180 degrees. But we know that x equals to 90 degrees minus alpha, so we can substitute x by 90 degrees minus alpha. Okay, so 90 degrees minus alpha plus y plus alpha equals to 180 degrees. Minus alpha plus alpha equals to 0, so we can eliminate alpha from the equation. So we got that 90 degrees plus y equals to 180 degrees. Now we can subtract 90 degrees from both sides of the equation, and we will get of that y equals to 90 degrees. Okay, y equals to 90 degrees. So actually the middle triangle is a right triangle because it has one angle that equals to 90 degrees. So we can write it here, and therefore we have three triangles that each of them are right triangle. This is right triangle because the sentence itself is about the right triangles, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we are talking about right triangles. So this triangle is right triangle, and the middle triangle is also a right triangle because we found now that this angle is 90 degrees, and the left triangle is also right triangle because we bent it like this. It is a copy of this triangle. We actually raised perpendicular to side B in size of A. So here we have also 90 degrees. So all the three triangles are right triangles, and it is very important because now we can calculate the area of each triangle very easily, because the area of a right triangle, actually it is the multiplication of the perpendicular sides between them, and then we will divide the result by 2. For that reason we made all that effort to find the angle of the middle triangle, because in this way we can calculate the area of the middle triangle. Okay, so actually we have here a trapeze. A trapeze is a square that has two sides that are parallel to each other. Side A is parallel to side B, and for this reason this is a trapeze. We actually calculate the area of this trapeze in two ways, and then so we will get two expressions, and then we can say that expression 1 equals to expression 2, because it is the area of the trapeze that is calculated in two different ways. So we will get the third equation, that expression 1 equals to expression 2, and from that equation we will derive the Pythagorean theorem. So we'll start with finding the expression 1 for the area of this trapeze. We can say that the area of this trapeze is actually the sum of its parallel sides, that is A plus B, because A parallel to B, A is parallel to B, so the sum of its parallel sides is A plus B times the height of this trapeze, that is also A plus B, and we divide all by 2. and we will call the area of the trapeze, we will call it S. So S equals to A plus B, that is the sum of the parallel angles, times A plus B, that is the height of the trapeze, all divided by 2. So we have the first expression for the area of this trapeze. Okay, now we will create the second expression for the area of this trapeze. We can say that the area of this trapeze is the sum of the areas of its components. It's just the sum of the areas of the three triangles that the trapeze composed of. It is the area of the right triangle plus the area of the middle triangle plus the area of the left triangle. The sum of these three areas of the three triangles equals to the area of the trapeze. So first of all, we will calculate the area of the right triangle. As I have already said, the area of a triangle is its base times the height to this base, all divided by 2. So the base of this right triangle is A, the height to this base is B, and we divide all by 2. So it is A times B divided by 2. So this is the area of the right triangle. The area of the middle triangle is the same formula, that is the base of the triangle times the height to this base, all divided by 2. So the base of the middle triangle is C, and the height to this base is also C. It is the height to the base because we have 90 degrees between the height and the base. The angle between C and C is 90 degrees. So it is C times C, all divided by 2. Okay, so it is C squared divided by 2, and the area of the left triangle will be equal to the base of the triangle times the height to this base, all divided by 2. So it is the base is B, times the height to this triangle, that is A, all divided by 2. So it is B times A divided by 2. Okay, so in total, the area of the right triangle plus the area of the middle triangle plus the area of the left triangle equals to the area of this trapeze. Okay, so now we have the second expression for the area of the trapeze. It is the area of the right trapeze plus the area of the middle. No, it is the area of the right triangle plus the area of the middle triangle. That is C squared divided by 2 plus the area of the left triangle, that is BA divided by 2. And the area of the right triangle is A times B divided by 2. Okay, so the sum of the areas of the three triangles equals to the area of the trapeze. So we have two expression for the area of the trapeze, and of course they equal to each other. Now we will create the third equation, that is says that expression 1 equals to expression 2. So a plus b times a plus b divided by 2 equals to a times b divided by 2, the area of the right triangle, plus the area of the middle triangle, that is c squared divided by 2, plus the area of the left triangle, that is BA divided by 2. Okay, so here we created the third expression that says that expression 1 is equals to expression 2, because we actually calculated the area of the trapeze in two different ways, and of course they are equal to each other. So as I already said, in the left side of the equation we have the area of the trapeze as we calculated it in the first way, and in the right side of the equation we have the area of the trapeze as we calculated it in the second way. That is actually the sum of the areas of the three triangles that the trapeze composed of. So now we will multiply the two sides of the equation by 2. So we will get that a plus b times a plus b equals to a times b plus c squared plus ba. So after we multiplied the two sides of the equation by 2, we got this expression a times b times a times b equals to ab plus c squared plus ba. Now ab plus ba is 2ab, so we will write it down. Okay, a plus b times a plus b equals to 2ab plus c squared. So in the left side of the equation we have brackets. We will open the brackets and we will do the multiplication. So after we opened the brackets, we got that a times a is a squared, and a times b is ab, and b times a is ba, and b times b is b squared, all equals to 2ab plus c squared. Again, we know that ab plus ba is 2ab, so we will write it down. So we got that a squared plus 2ab plus b squared equals to 2ab plus c squared. So we have 2ab in both sides of the equation, so we'll subtract 2ab from the equation. So the final result is that a squared plus b squared equals to c squared, and that is exactly what we wanted to prove, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so c squared equals to a squared plus b squared. Okay, again, the square of the hypotenuse, that is c squared, equals to the sum of the squares of the perpendiculars, that is a squared plus b squared. Okay, thank you very much.